Hello guys, today we learn about the STAAD Pro. In STAAD Pro we can plan it that G+10 with a water tank and open the STAAD Pro. Then structure will be like this. Open the new project and spacing and meters and kilonewtons. Then after click on the next and go to the spacing. Okay, here change G+10 with water tank. And spacing and meters and kilonewtons. Click on next. Go to the open visual structure and complete the page. Then after interface like this and go to the frames mode and by frames. Click on the by frames. Double click and in by face length height of length is 12 meters and height is 3 meters. Width is 12 meters and in the number of base along the length of the here what 4 means which is columns and beams is known as 4 and here 4. This is the floor. How many floors will be containing is known as the floor and click on apply. Like this structure will be available. Then close it and OK and click on OK. Then interface like this. Go to the go to the top view and go to the cut section and select view and window. Click on OK. Then select which side you want your wish and this side or this side or this side your wish. Which side you want, you click easily. Go to cut section and select view and windows and click on OK. Then drag it to select the one side. Then after go to the isometric view and select the beams. Please control the select the beams. Then go to the isometric and insert the node and click on the midpoints. Then click on OK. It will be coming on midpoints. We can go to the node cursor. We can see the midpoints like this. Then after select the midpoints and Control C Control V. The direction X direction minus 1. Click on OK. Why should we take it -1? It will be coming to the steps. I want the steps, so that's why I click it like this. And then after click on here and exit Control C Control V and direction of. We can see the directions here -3. It's down. It goes to downwards, so I need a -3. So click on OK. We can easily see the node points. And then after click on like here and Control C Control V. The direction of Z direction 1.5 I need midpoints. Here we can see the midpoints. Then after we easily added the node points here, 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 here. Then after we should add it here, 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 here. Then after we added the beam cursor here to here,
At
here
these
to
points,
here. For these points we added like this. Okay. Then after go to the whole structure and go to the node plates, added the node plates here for these points. Then after go to the translate repeated in direction of y direction. It's toward the upward direction. So what's my direction is y direction up to 10 floors, and the meter of the height is spacing is 5, and linked steps we should add it. Click on OK. Okay, first of all we select the control A. First of all we select the all structure, whole structure. Then after click on OK. It will be coming like this. Then after go to the node cursor. Go to the node cursor and select the node cursor, and same as its translate method, translate repeated y direction at the height of the at the steps of the 10 floors and the height of the meters of the 5 meters, and click on the OK. It is easily acted. We can see the like this. We can see. Okay. First we select the node points. Go to the node points, node cursor, and select the points. Which are the my points? Control C, Control V. Click on Control C, Control V, in the direction of height of the height of the height of the distance is the tank of the height is the 2 meters. Click on OK, and we can see the node points here. Then you click here. Then go to geometry and go to the connected beams along the x direction. Okay, and geometry, go to geometry, connect on the x direction. Okay, when we select the both we select the node points and go to the geometry and contact to the beam along the x direction. Okay, geometry along the z direction. By that we get the node plates of the structure of the tank, and go to the node plates and added the node plates. These points are should added. We can see them easily. which box we can apply the, you can see we added the 3 side only, so we can add this side and back side. Go to the node plates and select we can see, okay, we can see this side and downwards we not added the plate, so we should add the plates. Go to add cursor here. Okay, we added. Go to the cursor. We can see the tank. We can complete. We was completed the tank, and go back and go to the general and go to the define. Go to the rectangle. We're giving the sizes of the beams, beam and column size. This is the column size, and this is the beam size, and close it. Go to the thickness. This thickness is 0.15. My thickness is 0.15. We can easily assume, and close it. Go to assign it. First of all, we select the beams. First of all, we select the columns. So beams parallel to the Z direction. They are assigned to selected beams. Assign. Then easily assign, and go to the same line. Select beams parallel to the X direction and select beam parallel to the Z direction and assign those selected beams and assign. Okay, assign was completed. So go to the thickness and assign to view. Assign. Directly we can see the assign. We can easily see the 3D model. See, we can easily see. Then after, go to the loads and definitions. In the loads and definition, first we should add the seismic, and we should take the Indian code, IS code. Okay, we can easily in some systems will be get the generated. In my system it's not getting generated. So my zone is 1, and ST also here 1 added, and self weight will be also added, and close it. Then after wind load, go to the wind load, added, close. Go to the wind load and add in the custom calculate as ASC 7. Click on the option and open this. We select the category 4. Why? Because in the building calculation as we can taking as an assumption. This is the wind speed. I was selected Indian. Sorry, we selected Hyderabad speed and meters per seconds. We should select and next simply applied and go to the main building data. Then after the building height, building top of the building height, which is my height is 3 meters into 10 floors means 33 and here building length wind is 12, building length of the normal director by wind here also 12. Then go to the in meters, we should keep in the meters, and then after simply applied and go to the building design pressure and simply we can simply apply and click on OK. And here added, here exposure is 1, we should add. OK, close it. Then after we can assign to selected view and assign. Then after load cases details and we should add in the load case we should add seismic curve, earthquake x direction 1 and earthquake z direction, and next we should add the wind load also we should add the w wind load and the x direction and wind load the direction of z direction add, and dead load we should add at DL, and live load we should add at LL. Then after is close it. Then we can assign we can easily we added the which type of loads we should add it in the structure. Then we can assign in the earthquake x direction we should add and seismic load, go to seismic load in the factorial 1 x direction we should select the x direction and close it, and z direction we should add same like that only, direction will be changed same value. Okay, close it. Then next we should add the wind load. Next we should add the wind load. In wind load we should wind load cases and maximum range is 10 and minimum is 33 at the x direction, and close it and close it in that z direction. Okay, you can add it another one also. Yeah, range 10 and 33. This is the building height. This is the -1 we should give. Add +1 and -1 we should give the wind surface in wind z direction. Go back go to the z direction we should add the 10 and here 33 added, and here minus we should add it. Okay, add it, close it. Then after we should add the dead load. Dead load means self-weight load will be acted. Close it. Then after live load added. In live load we should added only plate loads. Plate loader we should added the pressure on the full plate is 3.75 in the direction of minus we should add it. Okay, close it. Then after we can assign it. Assign to selected view, assign to selected view, assign. uh, in the load cases we should add it. Then after go to the materials, we should add the concrete. Assign the selected views, assign. Next we should check it the analyze print. Add it, close and analyze. You can see the we did not give it support, so that was we got an error. And go to the general and support, click on supports, create support, add a picture support and click on the supports. Then go to the front view and go to the node plates. We should drag it like this and assign the selected view nodes and assign. Okay. Then after which analyze the print, close it and go to analyze, run analyze. See here, 0 errors and not worry about warnings. Go to the check it. We can easily we did not get an error, so we go to the design and select the parameters. We select and we first of all we should select the concrete material and go in ISC code will be 456 IS 456. We should select and go to the parameters, select parameters, throw away like this, throw away to left side and we should select the FC and F5 main, F by sec and max sec, max main and MD1 MD2 and main and main sec we should add it. Then after click on OK, go to the define parameters and FC will be 30,000. We can assuming add and F5 main we should select the for 45,000, sorry 4,50,000 add and F5 sec also I'm taking 4,50,000 add F5 main. F5 main check, this is the minimum rods and minimum rod is 25. F5 6 minimum 12. Here 10 mm I change to the 12 mm. Here change it to the 10 mm, so 16 mm added. F5 main we should add 12 mm, 10 mm added and close it. Then after we should go to here, go to comments, add, we should design beam added and design column we should add it and slab slab also added, take off the also added, and close it. Then after go to, we already selected values through, go to the assign to view, then go to here, assign to view, assign, here also assign to view, assign to view, assign. These all values we can assign to view and assign. Then after we should add the all of value to assign to view, assign. Then after we should check analyze print and click on analyze, go to analyze mode, analyze control S. We can see, wait for the errors or we can see the 0 errors, and then after we should go to the post processing mode and click on the OK, applied all. Okay, then go to the apply all and click on OK. Then after go to the animation, deflection, any deflection we can see the deflections here. Live load deflection like this will be available, and at the deflection, this is X direction, this is the Y direction, Z direction, this is the vendor, and this is the vendor dead direction, this is the dead load, this is the live load. Then after go to the apply. Okay, we can see the momentum, shear force, and shear for Z direction. This is the moment, this is the bending moment in Z direction, and beam pressure and beam plate pressure. This is the plate pressure. Then after go to the then go to the foundation, and here click on the including all load cells and run start pro foundation. We can see the footings of all this in the foundation. We can see the all footings which we can easily find it in the foundation process. Go to the loads and factors, click on the loads and factors, then go to the general loads combination, click on the general load combination. Then after click on the Indian, we should select the Indian. We already selected Indian, so that's why we selected Indian. We should update the table. It will be easily to generate the loads combinations, and here also update the table and generate the loads and combination. Okay, then after go back, go back to job. Next we can find it the job setup and create the job setup, and here we should give the name. My this is the structure name is G+10 with water tank. G+10 with the water tank. Then go to the design code is the India here, yes, and that's it. Go to the including all load cases, create a job. Next create a job, then after go to the in the left side we can isolate footings and jobs we can take, and in that design parameters will be there, and go to the design parameters we can see the which which loads will be, foundations will be, we can see, and go to the generator design, and yes, we can wait for the calculation sheet. We get the footings, how many footings we get here. Design per isolated footing 56, we get the 56 footings. Like this we can see the footings graph. In the detailing whole structure we can see the whole structure of the detail and sheet, and this is the GA graph, and this is the calculation sheets. That's it. Thank you. That